Hello friends, this video on ray optics part 43 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 42 before going ahead with part 43. Let us now look at the image formation by eye. As I mentioned before, that image is always formed at retina. So how this image formation takes place? This is the eye lens, right? Just now we saw. Now let us suppose this is my object. Let us say this is my eye and I am looking at this small child. So this is my object. So the rays coming from this object will enter the eye. It will undergo refraction and it will form an image like this. That is a real inverted image will be formed at retina. But do you think that when we view something, we see it inverted? No, we see an erect image. Then who converts this image again back to an erect image? It is nothing but brain. So connecting this eye with the brain, connecting eye to the brain, there comes the role of rods and cones. That is the receptors which are present on the retina. So this is how an image formation takes place by the eye. Right? Now, as I mentioned before also, that focal length of the eye lens is varied by ciliary muscles. So ciliary muscles play a very important role in image formation or in the functioning of the eye. So if the ciliary muscles are not working properly, or if the flexibility of the ciliary muscles decreases, then the functioning of the eye also gets affected. So now I'll tell you the importance or the significance of ciliary muscles in the functioning in a better functioning of eye. Let us suppose if we want to view an object which is at a very far off distance, because till now I have been telling you that the image will always form at retina. So a question might arise in your mind that so far we have studied about the image formation by a convex lens. So what did we see? That as the object distance, as the distance of the object keeps changing, the position where the image will form also keeps changing. So how can we say that every time the image will be formed at retina? Because we see so many things around us. Sometimes the things are very near, sometimes they are so far off from us. So that means the object distance is changing. So in that case, the image distance should also change. But in this case, the image distance is always fixed, that is the retina, if your eye is functioning correctly. So how is that possible? That is because in those scenarios which we talked about before, we always assume that we have a fixed convex lens, right? Which has got a fixed focal length. But right now we are telling that we have a convex lens whose focal length is adjustable. The focal length can be increased, the focal length can be decreased. So by increasing and decreasing the focal length, we make sure that no matter wherever the object is placed, the image should always be formed at retina. So how that adjustment happens? Let us suppose if when the eye views an object which is a distant object, in that case the rays are parallel rays, because it is a very distant object, so we don't know from where actually the rays are coming. So this is how the image formation will take place. In this case, if you see the lens will adjust its focal length in such a way. How do they adjust it? When it is viewing a distant object, then the ciliary muscles will get relaxed. So the ciliary muscles will let themselves loose. As a result, the focal length will increase. So if the ciliary muscles relax, in that case, the lens will flatten out. So the lens becomes thicker. As a result, the focal length is increasing. Now, maximum focal length. So focal length increased, and what can be the maximum focal length in this case? The maximum focal length that is possible is the retina, because this is the end of the eye, right? Retina was the last thing in the structure of the eye. So beyond retina, it cannot increase. So that means the maximum focal length possible is the retina. Now, what do we know? For a convex lens, if the object is at infinity, where is the image forms? The image forms at focus, right? So now we have increased the focal length in such a way that the focus is at retina. So therefore, the image will also form at retina. So this is what happens when the object is placed at infinity. So let me write it in points. So when the object is at infinity, what will happen? First of all, the ciliary muscles will relax. Ciliary muscles will relax, as a result of which focal length will increase. So maximum focal length will be maximum at retina, right? Now since the object is at infinity, therefore the image is at focus, right? And what is focus? Focus is nothing but retina. So therefore the image will be formed at retina. So now let us look at the scenario of a nearby object. Now let us suppose that if the eye is looking at a nearby object, let us say the eye is looking at this ball. So in this case, one ray coming parallel to the principal axis, it will pass through the focus. In this case, this is my focus. In this case, what happened? The ciliary muscles contract. So the ciliary muscles contracted. As a result, the focal length decreased. Now when the focal length decreased, right now the focus is here. In this case, the focus was on the retina. Focus reached its maximum value. In this case, the focus is here. Therefore, a ray coming parallel to the principal axis passed through the focus. Another ray which passed through the optical center of the lens went without any deviation, and they both met at this point. Which is nothing but again the retina. So that means if we bring this object even more closer, in that case the ciliary muscles will contract themselves even more, and therefore the focus will shift even more towards the lens. So this is how we can view objects at different locations. By changing the focal length of the lens, we can make sure that the image will always form at retina. And whenever the image is formed at retina, we can view that object. We get a sharp image. That means we can view that object very clearly. So for any eye without any defect, because mostly you would have heard complaints of your grandfather or grandmother that during their old age, they are not able to see things clearly. So the visibility decreases. That's because with old age, the functionality of this, or the flexibility of the ciliary muscles decreases. So the ciliary muscles are not good enough to contract and expand as and when needed, and as a result, the change in focal length is also not very smooth. Therefore, sometimes they complain that they are not able to view distant objects clearly, or sometimes they also say that they are not able to see near objects clearly. So what I mean to say is that if your eye is functioning correctly, in that case, the image will always be formed on the retina. Right? Okay. So now let us talk about something called least distance of distinct vision. So what is this least distance of distinct vision? It is the closest distance for which the lens can focus light on the retina. That means the closest distance for which the lens can make sure that the image will be formed on the retina. Because I told you how the image is formed on retina, because when the object is at infinity, the focal length is maximum. Now as the object is brought nearer, the focal length keeps decreasing, right? So every time it decreases in such a way that the image is formed on retina. But now the ciliary muscles also have a limitation to adjust themselves, right? So there is a minimum focal length beyond which the focal length of the lens cannot decrease. So now this distance, the distance of the object corresponding to that minimum focal length is known as the least distance of distinct vision, because beyond that the image will not be formed on the retina. As a result, we will not be able to see the object clearly. So this distance is also known as the near point. So that means if an object is placed closer to near point, in that case the image is not very clear. I mean the image is formed even before the retina. So here you can see that in this case what happens, the image is not formed on the retina, the image is formed beyond the retina if the object is at a distance lesser than 25 centimeters. So this is what we know as least distance of distinct vision. Now in this case, another point which I would like to add is that an example, in fact, as I mentioned before, that you would have seen that people during their old age, they often complain that they are not able to see things very clearly. The view is not very clear. That is because the ciliary muscles lose their flexibility with age. So as a result, they are not able to expand and contract smoothly as and when required. As a result, the change in the focal length is not very smooth, and therefore the image formation does not take place on the retina. So the image is either formed before retina or the image is formed beyond retina. So as a result, the object is not viewed properly. Let us now talk about apparent size of an object. What do I mean by apparent size? The term is similar to what we studied in refraction, right? Apparent depth. We talked about real depth versus apparent depth. So what was that real depth? Real depth was the actual depth of an object, and apparent depth was the depth which is viewed by the observer. So what we see is apparent. So similarly here also we are talking about apparent size, that is the size of the object which we see, the size which we are seeing. It is not talking about the actual size of the object. So it says that the size of the object which we see, that is the apparent size, depends on the visual angle. What is this visual angle? It is the angle through which we are viewing the object. That means the angle subtended by the object on the eye. So what is visual angle? Angle subtended by the object on the eye. Let us suppose if this is the object this is the object and this is the eye. So now the angle which this object subtends on the eye is theta. So it says that the apparent size. Now what is the size of the object that is formed? In this case, this would be the size of the image, right? So it says that this apparent size depends upon this angle theta. How? Let us see that. Let us suppose that the same child, that is the same object, is now located at a far off distance. And this is the eye. So in this case, what happens? What is the angle subtended by this object now? So now it is somewhat like this, even though the size of the object is same in both these cases, but just because the angle subtended in this case is different, therefore the apparent size in this case is also different. Therefore we say that the size of the object which we see, it also depends upon the visual angle, that is the angle which the object subtends on the eye. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.